why is it that the sinuses are so foundational in CIRS? Let's kind of just highlight the very basic mechanistic sequence that tells us that the sinuses are the entry point into CIRS. And I've always said that CIRS starts in the brain, and if untreated, it ends in the brain as well in a different format. But the reason why it starts in the brain is because of what we're about to talk about. So I'll just show you a sequence here. Hopefully it makes sense. I'm oversimplifying, but I just want to make sure you get the idea, right? So we start with the basic premise that biotoxins trigger inflammation in the sinuses. You walk into a moldy environment or an environment with a lot of endotoxins or actinobacteria, the first thing that's going to happen to your body is you're going to breathe all of that, and it's going to go all through here, right? Your upper respiratory tract, you're breathing that, and that's your primary source of exposure. This is true for any human being, right? When we walk into spaces where there's a high load, that for people who are CIRS susceptible, they're going to be prone to triggering a lot of inflammatory activity in the mucosal linings that are in the sinuses and these upper respiratory tracts. And so that's kind of the first step here. And so because we have this HLA genetic susceptibility, what does that mean? It means that when we encounter these sequences, this inflammation can start becoming chronic. It's inflammation from what we call the innate immune system, your first line of defense, and your first line of defense is very active in those mucosal tissues that are all over here. So biotoxins come in, they're going to trigger that innate immune system. And in our case, it can become persistent and chronic because we're not good at turning off that initial inflammatory response. We're really good at turning on that innate immune response. We're not so good at turning it off. So that chronic inflammation exposes the pituitary gland, right? And it also includes the hypothalamus. That's your hypothalamus. This is the pituitary gland. They're deeply interconnected. I want to add that the pituitary gland is extremely vulnerable already because it's not even protected by the blood-brain barrier. You can't see it in this picture, but around the brain, there's going to be this blood-brain barrier, thin layer that protects the brain. The pituitary sits outside of that. So when you have all that inflammatory activity from the biotoxins triggering your immune system, it's going to expose the pituitary to that inflammatory activity. Inflammation in the pituitary for us means dysfunction of particular biomarkers, or in this case, hormones that regulate our body. And we've talked about MSH a lot and all the things that MSH is for our bodies. But one of the core things that start happening is loss or dysfunction of MSH that eventually will start becoming deficiency. We start losing our ability to produce MSH, which is secreted here in the pituitary gland. I'm going to get a little more specific here. In the what we call the anterior portion of the pituitary, and anterior simply means you can think of it as frontal, kind of facing this side, right? This portion here, the pituitary can be subdivided into all these different structures. And the portion that's most vulnerable is where MSH is most active and produced, essentially. So that's taking all that fire very easily. And this is why you start seeing so many times dysfunction of MS in patients. And that's when we start to get into more increasingly more complicated situations that look more and more like CIRS. So we're poking our body to turn on CIRS and to turn on those genes that are responsible for CIRS. Loss of MSH, there's a bunch of consequences here. I'm not going to go over all of them for our purposes today. This means there's going to be a lot of susceptibility for dysbiosis all over these tissues, right? So when our immune system is working properly, those barriers are nice and tight and sealed and well protected. You have a very symbiotic system, much like the gut. And so when you lose MSH, there's a lot of unresolved inflammation that can start degrading those barriers. And then suddenly you start having a very dysbiotic situation. And so microbial dysbiosis means risk for certain bacteria to overgrow. It's not that they necessarily are present and that's it. And in fact, if you have a healthy immune system, healthy mucosa, you can see all kinds of bacteria, some of which could be potentially threatening, but they're kept in check. They're managed by the immune system and the mucosa, that barrier. And we now have enough data to suggest that there are two classes of organisms right now that seem to be very problematic in the context of what I'm talking about. But this is the mechanistic sequence here, right? This is where we run into trouble. Anytime that the pituitary and the hypothalamus take those massive hits, you are basically poking or inducing CIRS in your body. And that's the origin, the genesis of all these symptoms that we have: chronic pain, sleep problems, eventually maybe like mineral water retention problems, eventually brain fog. Eventually those things start creating opportunities for fatigues and all these things that we start experiencing downstream. But this is just the entry point of all of that. And so as long as those regions remain fully exposed, vulnerable, and inflamed and in dysfunction, you don't really have a reasonable chance to regain your body in CIRS.